This is The Future Of, where experts share their vision of the future and how their work is helping shape it for the better.
Hello, I'm Tom Robinson. Climate change may have taken a back seat during the COVID-19 pandemic, but its effects and challenges continue to pose very real threats to humanity. In order to prevent extreme weather events like the bushfires we've seen in Australia and now California, as well as rising sea levels, warmer temperatures and the depletion of food and water, we need to rethink how we use our natural resources. So today we're talking about sustainable engineering. Sustainable engineering is exactly what it sounds like. It's about making engineering more sustainable and figuring out how we can use our economic, environmental and social resources more efficiently into the future. To discuss this topic with me today are Professor Michele John and Associate Professor Wahidul Biswas. Michele is Director of the Sustainable Engineering Group at Curtin, and Wahid is an Associate Professor in Curtin's School of Civil and Mechanical Engineering. Thanks for coming in today.
Nice to be here.
Nice to meet you.
Michele, sustainable engineering sounds like the ideal solution to a lot of humanity's problems, but are you able to expand on what it is?
Thanks, Tom. Yeah, sustainable engineering certainly holds a big part of the solutions we need for climate change and also for sort of sustaining the world into the future. One of the first climate reports that was done on the world needing to recognise that climate change was a big issue noted that 70% of the solutions that were required to solve climate change into the future required engineering decisions. So engineers are really at the heart of that potential to provide ongoing support in renewable energy development, in material efficiency, and very importantly, reducing the environmental impacts that our production and consumption decisions have on the world.
Wahid, what were your thoughts on that?
Yes, I think sustainable engineering deals with energy efficiency, renewable energy, clean technology to achieve economic, social, and environmental objectives of sustainability and to leave a better world for our future generation.
It includes, I guess, this focus that the Brundtland definition of sustainability acknowledges that the world is a finite resource. There's one planet and an exponential growth in population. As a result, we have to make sure that future generations have the same access to resources and a clean and desirable environment to live in as we have now. So sustainable engineering is about making sure that the engineering decisions we make include that in our decision making.
Can you tell me about some of the projects you're working on surrounding sustainable engineering right now?
So we are working on the use of byproduct and converting byproduct to resources. And at the moment, we are running a project which focuses on the conversion of incinerated bottom ash to civil construction materials. And this incinerated bottom ash is produced in waste-to-energy plant. And the waste is diverted to electricity in this waste-to-energy plant. And if they are not reusing this incinerated bottom ash, if they're disposing it to landfill, then they're not actually solving the landfill problem. So what we are going to demonstrate that, yes, it can replace some energy intensive and expensive materials like limestone and crushed rock, so that it will help waste to energy plant to achieve a zero waste target. On the other hand, if we're avoiding the use of limestone or crushed rock, we can avoid quarrying, crushing, all these energy intensive activities. So all these things have social, economic and environmental benefits, and we will, as Professor John has already mentioned, these activities can help conserve resources for our future generation, and this is a large component of industrial ecology.
It's an important point, I think, to note that Wahidul and his expertise in sustainability is focused largely on life cycle assessment, the impact of our resource decisions on the carbon footprint as well as the resources that we consume and what we leave relative to the future. So a lot of the work that we've done has been focused on sustainability assessment. It's, I guess, good management practice to understand what the impacts of our engineering decisions are in order to improve them. So if you look at our website, there's a lot of life cycle assessment, I think, in industrial ecology. We're world leaders in that realm. But additionally, if you think of sustainable engineering and you look at the broad array of topics that Wahid and I get involved with, it's focused largely on resource efficiency. It has a very significant focus at the moment on renewable energy production. We have a very big amount of research being done around circular economy principles and waste management. Fundamentally, green design, eco-design is essential within sustainable engineering decision-making, and cleaner production from a pollution prevention point of view. So that probably summarises the breadth of sustainable engineering decisions that we cover, but we are renowned for Wahid's particular expertise in life cycle assessment. That really is a critical tool to modern sustainable engineering.
What will the world look like if we continue to rely on fossil fuels for energy and use resources and materials the way we are at the moment?
That's a good question. We know that we have one world, one planet. We know that the oil resources and the coal resources we have are also finite. We saw some very significant modelling done in the 1970s, the limits to growth modelling by Donella Meadows and her husband Dennis, which showed the impacts of exponential growth and carbon consumption on the world, both in its effects on the clean air and the agricultural production and industry's ability to continually consume resources that were in finite space. And that's not a pretty picture. That's one that we simply have to learn from. So fossil fuels has created the Industrial Revolution, which has given us, very importantly, the wonderful standards of living that we have. But at this point in the juncture of humanity, we've got the Chinese and Indian populations, which will literally represent 50% of the world's population by mid-century, also wanting to achieve the same standards of living we have. But there's a very significant imprint involved with what we've consumed, and now we're going to double that imprint just at a time where we know with the need to decarbonise the world, we need to be moving back from that carbon consumption, not allow 50% of the world's new population to increase it. So sustainable engineering says we need to really take stock of that carbon. Decarbonising our energy consumption in our general production activities, manufacturing activities, is critical. That's going to be a very, very important part of modern engineering going forward.
In terms of that global perspective, is sustainable engineering something only wealthy, developed countries can afford, or is it something that countries all around the world can have a look at?
I think sustainable engineering is important for both developed and developing nations. In the case of developed nations, I think engineers need to focus on technological development, improvement, because scale of production is an issue. In developing nations, also overconsumption is an issue in developing nations. But engineers are coming up with innovative technologies to reduce consumption. In the case of Western Australia, seawater is converted to desalinated water, and it requires huge amount of investment, but this is not a problem. And most importantly, it is run by renewable energy technology. It is powered by renewable energy technology. But the context is different for developing nations because affordability is an issue, and engineers' challenge is to eradicate or alleviate poverty by developing low-cost technology, low-cost water purification technology. For example, engineers have come up with electricity generation technologies that can convert waste to biogas. Also, that technology can produce fermented slurry that can replace chemicals, and biogas can be used for electricity, for irrigation purposes, lighting purposes. It means that the people in the developing country, they don't have much non-renewable resources, and they're experiencing resource scarcity. They cannot pay for diesel and other. So engineers, they have spent time, or they have come up with innovation to use indigenous resources to make their life easy and sustainable, which is economically, environmentally, and socially viable.
Is sustainable engineering expensive?
No, I think it's a paradigm that's often held. I think in the early space, the cost of renewable energy was more than that generated by fossil fuel power production, and so it was initially assumed to be, but I think the level of technology development that we've seen in the last 20 years has shown that to be sustainable is probably going to be a lot more cost efficient. And that cost efficiency is also going to allow us to continue our production and consumption activities into the future. I think another really important element of sustainable engineering, which is an important part of the education programs that we deliver, is that there are going to be governance and stewardship responsibilities inherent in the sorts of decisions we make around sustainable engineering. And increasingly, we see environmental and social governance issues starting to be raised. So if we're going to be involved in that sphere, if the community is going to expect it, if the increasing levels of regulations on our production activities are going to expect it, then we need to have that as a natural culture within an organisation, have it embedded within our engineering decision making to ensure that those outcomes are actually achieved and can be proven to be accountable and transparent to the community. I think the expectation for the current generation of engineers that we're educating, they're going to have to meet much higher standards of both regulatory pressure and community expectation from having engineering decisions that are much more focused on sustainability outcomes.
Did you have any thoughts on the price of sustainable engineering in an economic sense?
I think sustainable engineering can help achieve long-term benefit. So initial cost may be high because we are investing money on clean technology, renewable energy technology, energy conservation measures. So initial cost may be high, but we can save large amount of resources, there could be large amount of financial saving, and that can easily offset the incremental cost. So it has got huge sustainability benefits in terms of economic aspect, environmental aspect, and social aspect, because we will be able to leave adequate resources for our future generation in an economically feasible way.
What are some of the current challenges preventing progress in sustainable engineering?
Of which there are many. I think in Australia there's been a significant lack of political leadership in the sustainability realm and the debate over climate change pressures for the last 10, 15, 20 years, which has been problematic. I think the lack of a carbon tax and the recognition that if we're going to decarbonise, we need some serious regulatory pressure on us to push us down that direction so that all companies are operating on an equal platform. I think the fossil fuel dependency of our transport systems in a country like Australia, which is very large and we all rely on cars for sort of 30, 40 minutes twice a day to get to the office, that's another element. I think the focus towards green energy starting, renewable energy, there's an enormous uptake of solar PVs on nearly a quarter of Perth homes, so that's a very important focus for people to start recognising, I can do this myself, I want to contribute myself. And I think there's the need also for some of the challenges to be spoken about and to be educated more. I think when we look at a lot of the education structure in engineering across Australia, there isn't enough focus on the need to see sustainable engineering as an implicit element, a core sort of philosophy and core outcome of everything we teach in engineering.
There are clearly some challenges facing sustainable engineering and environmental movements in Australia. What is the potential of this country, though, in terms of sustainable engineering? Is it something, could we be successful with it? Could we be a sustainable engineering powerhouse, if you like, as Australia?
Absolutely. Australia could also be key in the development of the green jobs economy. Absolutely. That's a really formidable future for us. It obviously requires a significant amount of government policy in directing it, and certainly universities getting behind it. But the potential for that, given the amount of solar PV that we have, the natural resources we have in terms of hydropower also. We are a young economy. We've got a very young base of educated engineers now coming through. We've used a lot of the resources we've produced literally out of the ground and sold them on to major economies to produce, and then we buy them back. I think the time now is for Australia to sort of look at what we're selling in those resources, look at decarbonising them to reduce the overall footprint, and for us to recognise there's a lot of technology that we could be developing in and around sustainability, like the future battery CRC, moving towards a future where we don't have to rely on fossil fuels. Solar energy is an enormous one. And I think the whole environmental protection of the value we have as resources in Western Australia and standing new metrics, new systems for managing those resources are an important part of being green. Our agricultural production has an enormous potential to look at becoming a lot more greener. And I think the element that's going to drive a lot of this is climate change, the need to really manage risk a lot more than we've ever had to consider before. And we also have a new generation that are coming through that in another 10, 20 years will be in management positions who will take on the whole position of sustainability, stewardship and governance a lot more seriously than perhaps we've done in the past.
Climate change is a big issue. I think it is affecting our economy, and like bushfire incidents that is happening in California, that happened in Australia. This is because of the increase in temperature associated with the increase in concentration of carbon dioxide, anthropogenic emission of carbon dioxide in atmosphere. So, and we need to move away from coal, we need to move away from fossil fuel, and Australia has got plenty of renewable energy resources to meet 100% energy demand, plenty of wind, plenty of wave energy, plenty of solar energy. So I think climate change is a very scary issue, and we need to change now, act now, otherwise we will not be able to reverse the situation.
As an individual, and as individuals who are listening to the podcast, what are some of the things we can do to mitigate our carbon emissions and to take on some of the principles of sustainable engineering?
Well, fundamentally, I think we all need to recognise that sustainability has to be a core part of what we wake up and think about in the morning right through to when we go to sleep. So the energy we choose is renewable energy. The transport that we're using, electric vehicles are a small part of the realm at the moment, but share riding, walking the distance, taking consideration of the fossil fuel impacts we have in our daily lives. I think planting trees in your garden to help sort of the uptake of CO2, that's a very important part in a warming environment, particularly in Perth, recognising that having concrete around your house, turning your air conditioner on, these are all negative impacts. Trying to sort of cool the natural environment because the urban heat island effect is going to be quite significant in Western Australia. I think fundamentally speaking about it, reminding each other of our sustainable production and consumption responsibilities so that we all chip in, and I guess we share that sustainability ethos with our families and friends so that the political pickup, the policy pickup also starts to recognise that there is an expectation that we need to think about our current production and consumption models very differently if we want to see a sustainable future for the next generations.
Wahid, what do you think we can do as individuals?
Yeah, I think what Professor John has mentioned is absolutely right. In addition to this, we can use energy efficiency measures, and we can use end-use energy efficient technologies to use LED instead of compact fluorescent lamp. It may cost some money, but in long term, we are actually saving large amount of electricity bill. So if we are saving electricity at home, we are actually avoiding the generation of electricity in coal power plant or fossil fuel power plant. It is actually reducing the conversion of fossil fuel and reducing greenhouse gas emissions. And another thing is that we need to use less energy intensive materials like recycle aluminum instead of virgin aluminum, recycle steel instead of virgin steel, because if we are using recycled metal or material, we are avoiding all upstream activities, emissions, CO2 emissions associated from mining, processing, smelting can potentially be avoided. So in order to make it happen, we need to think during the design stage of the product so that after the end of life, the product can be disassembled, recovered, reused. So we can recover these rare earth materials, we can recover these energy intensive materials so that and we can repurpose it, we can remanufacture it, recover it, so we can avoid all these upstream processes means that we can reduce significant amount of carbon dioxide emissions. So this is a concept that we teach our students in industrial ecology, that if we are able to reduce the sink, which is landfill, by turning end-of-life product to a new product, we can automatically reduce the source, means mining, processing, and we can increase the carrying capacity of Earth to leave plenty of resources, land resources, natural resources for our future generation to achieve sustainability. That's the thing.
These are good points made by Wahid, because in life cycle assessment, we know that America, Australia, Europe have consumed at their current rates the whole planet's resources, to the extent that if China and India wanted to consume at the same rate as we have over the last 50 years, we need up to 6 planets, 6 Earths. Well, good luck with that and getting to Mars to sort of find those resources if you think they do exist. It's not going to be possible. We're going to have to rethink the production and consumption model we're in. And I think a really important element that comes to us in terms of what we can each do is look at our own workplaces and ask the questions, how can I improve the sustainability performance of my work environment? If you're in a management role, you might be able to influence the governance decisions that make those, part of those decisions, guide that training and education. You might be in an engineering role that can influence the materials or the energy choice or the waste decisions, which are really critical. So it's stepping up to the market and recognising that we all have to have some impact on sustainability, and we've all got an opportunity to do that. And now's a really good time to start thinking about what we can individually do.
Before we wrap things up, is there anything you'd like to add?
Thanks for the opportunity of speaking today. It's a wonderful opportunity to talk about sustainable engineering from an industry perspective as well as an education perspective, and they're really equally important. We find increasingly companies are coming to us and asking us to help them develop solutions around their waste management or the efficiency, the eco-efficiency of the technologies they wish to use. But also I think there's a values change, there's a governance responsibility that's now starting to emerge, and that's really important for us because we sit in a university that prides its model of education, and in the engineering school there are 2 or 3 fundamental units we teach across the entire engineering degree that focuses on engineering from a sustainability management perspective, and that really is critical. But to see more green champions being developed in industry, for industry to start looking at sustainability from a positive perspective, that it can reduce costs, improve their waste management, reduce their resource bills, and improve their community engagement and PR, I guess, around the branding, and that's been shown in the media in recent times can be a double-edged sword. That's really powerful for us, and that's really something that we look forward to working with industry to improve those outcomes for them.
Yes, I think engineers play a pivotal role in achieving sustainability, and they can generate a large number of sustainable development pathways through recycling, reusing, recovering, remanufacturing, reducing, all these activities. And after the World Summit in 1992, a group of engineers identified there were 2,500 issues, and of these 241 issues are directly related to engineering activities, and 1,700 are indirectly related to engineering activities. It does mean that engineers play a pivotal role in achieving sustainability, and they can help achieve energy efficiency, they can help in resource conservation, they can help in reducing pollution, they can help in developing affordable technologies. So engineers are a very big component in achieving sustainable development.
These are clearly very important issues as we move forward post-COVID-19, and clearly engineering has a big role to play in that. So I think we'll leave it there. Thank you, Michele and Wahid, for coming in today and sharing your knowledge on this topic.
Thank you very much.
Thank you very much, Tom.
You've been listening to The Future Of, a podcast powered by Curtin University. If you have any questions about today's episode, you can get in touch by following the links in the show notes. Wherever you're joining us today, don't forget to like, comment and subscribe. Bye for now.